All right, so let me try and show you how these functions are used with, you know, taking an input and getting an output with these functions. So we're going to go back to an example that we've seen previously. I think this might have been the weight of men in the United States or North America. I don't remember, where the mean weight was 190 pounds, and this was normally distributed. So what we're going to do is we're going to use a PDF function. Now remember, PDF functions will give us values along the curve itself. It'll give us ordered pairs, okay? And an ordered pair is an X value with a related Y value. So if I were to put in 190 into a PDF function, it'll give me as an output 0.0399, which is the ordered pair for this point right here at the very top of the normal distribution. And that can be calculated using both the Texas Instruments and the NumWorks PDF functions. So let me bring both of those up, and we'll see if we can do both at the same time. Okay. So first, on the Texas Instruments, we want to get to the distribution functions. So you can see it's distribution in blue. So I'll hit second, bars, and you can see here it's showing me normal PDF. So I'm going to click enter. So now it wants the X value. So the X value that we're going to put in is going to be 190. The mean of the distribution is 190. The standard deviation, if I remember correctly, was 10. Now, right now, it's just coincidence that our X value and our mean is 190. They're both 190. That is by choice. It won't always be that way. Okay. You might want to look at another value of X on the distribution. So this number will be different from the mean of 190. Okay. So we'll go ahead and hit paste. And you can see now it's showing you the normal PDF function with the inputs surrounded by parentheses. So the first input is the X value, and then a comma, the mean of the distribution, comma, and the standard deviation of the normal distribution, and then right parentheses. So notice each of the inputs are separated by commas, and they're all contained within parentheses. And if we click enter, okay, it says 0.0399 if we round it to 4 decimal places. Now we can do the same thing on the NumWorks calculator. Once again, we go to the calculation app. Okay. So again, here's our apps. We want the calculation app. Okay. And now we want to go to the toolbox. We'll go down to probability, distributions, normal, and then we want to go to normal PDF. And click OK. Now, let me, now it's asking for the exact same things. Now they just kind of disappeared. Let me delete this. Okay. Only because I kind of went really fast over something. So if we look at normal PDF, so the first value it wants our value of X, comma, then the second value it wants is our mean, comma, followed by the third value it wants is a standard deviation. So you can see the inputs are the same on the NumWorks calculator as they are on the Texas Instruments. So we want to be able to put the same thing in that we did with the Texas Instruments calculator. So let me click OK. And then I'm going to put 190, 190, 10. right parentheses. And if I click execute, it's 0.0399. All right. So same answer. And what we did is we put in the information for our distribution, which was a mean of 190 and a standard deviation of 10. So here's our distribution, where the center of it is the mean, which was 190, and it has a standard deviation of 10. So that's why it goes from 190 to 200 and 190 to 180. Okay, standard deviation of 10. And since we put this information about the normal distribution, we then put in a value of x, which was 190, and we wanted to see what value of y was related to 190. And the value that's related to 190 is 0.0399, which is this point right here at the top. And you can see we got those values on both calculators. Okay, now we can use these same functions to get more points on the normal distribution, and that's what a PDF function does. A PDF function just gives us ordered pairs on the edge of the distribution itself. Okay, it has nothing to do with the area, just values that are on the line of the normal distribution itself. Now, I'm gonna show you something that I just thought a few minutes ago. I think maybe I can try and do this graphically. You can see here on the left, I kind of ran this normal PDF function over and over and over again. But I thought, let me try something. So this might not work. Let's do a bunch of them at once and then see if we can graph them and see how that looks. Okay, so how might we do that? So first I'll do the Texas Instruments calculator. So I want to go to the list editor. I want to edit it. All right, so I got a bunch of values here I don't want. So let me get rid of all of these at once. So I can do that by hitting second and the plus key, which will put me into the calculator memory. And I can go down to the fourth option, which is clear all lists. Now they should all be cleared. There we go. Okay, so the first list, I want to put the various x values that I want to calculate y values for. So that would be 160 and 170. You can see that these points that these values here, 160, 170, that's these values here, 160, 170, 180, 190, because I want to create all of these points. I want to calculate all these points here on the normal distribution. So let me keep going with that. So 170, 180, 190, that's our mean. 200, 210, and I think we can stop at 220. Oops. All right, let me show the compatible version of that here on the NumWorks calculator. So let's go back to the applications, and I think this is going to work. Let's go to regression, because we're going to be graphing points. So it's going to be like graphing a scatter plot. So I'm going to click OK. And for the x values, I'm going to put in those same numbers. So 160, 70, 180, 190, there's our mean, that's the center, 200, 210, 220. All right, now let's flip back over to the Texas Instruments. So list 2 is where we want to put our y values. that are related to these X values that we put in list one. And so here we want to use the normal PDF function. So I hope this works. So to get to the normal PDF function, again, it's in the distribution menu, distribution options. So let's second vars, and I'll put normal PDF. And actually, before I do that, let me go back and show something. So we're going to be putting in a function to calculate out all of list two. So you want to make sure that the cell that's currently selected isn't this first row, but the cell that you have selected is actually the column heading, because you'll notice it says list two equals. We're going to put a function here, and that's going to program list two to be based off of everything in list one. Okay, so make sure list two is selected. Okay, so let's go back to the distribution functions. We want normal PDF. So I'm going to click enter. And our list of X values isn't going to be 190. Let's make that list one. So to get L1 or list one, you see it's got L1 in blue above the number one key. We'll hit second and one, and it should put an L1 in there. Now I'm hoping this is going to work because we have a mean of 190 and a standard deviation of 10, and we'll hit paste. There we go. So it's going to take all these values as inputs into the normal distribution with a mean of 190 and a standard deviation of 10, and it's going to calculate Y values for each of those. So I'll hit enter. Ah, it didn't like it. All right, I was afraid that was going to happen, but I thought I would try it. Let's see here, wrong value or variable type entered. Attempted to store a matrix to a list. Okay. Well, I was really going to I was hoping that was going to work. And it didn't. So let's see if the numworks calculator will do the same. Otherwise, we may have to do this piecemeal. But let's see if the numworks calculator will do it. So we can similarly program this Y1 column to contain values calculated off the X1 column. If we select it first, we click OK, and then we'll put fill with a formula. And I'm going to put empty. So now it's saying Y1 equals. Now I'm going to hit the toolbox, go down to probability. Yeah, this may not work, but I'm going to try it. There's only one way to find out. So let's do that. Okay, so we want our values of X to be this list here in X1. So to get capital X1, we need to hit Shift Alpha and then the number 2 key. So see, it has this letter X here. That puts a capital X1. Okay, and then the next value should be the mean of the normal distribution. And then the next value should be the standard deviation. Now let's see if it gives me the same, an error. No, it liked it. All right, so I could do this on the numworks calculator, but I could not do it on the Texas Instruments calculator. And so notice that previously, when we put in a value of X of 190, we got a value of Y of 0.0399. So what we ended up doing is kind of repeating this calculation. So we ended up repeating this calculation, but now we could kind of do a batch set of calculations here. Okay. Now, there's a reason why I wanted to do this, and so I'm disappointed I couldn't do it on the Texas Instruments, but let me show you kind of how to do a bunch of these calculations here on the Texas Instruments. So let me quit out. And so what I can do is I can just come up here to this normal PDF function I used earlier, hit enter, and change this to 200, and then hit enter. And when we put 200 in, we get 0.0242. And you can see here at 200, you get 0.0242. It's the same value. So on the Texas Instruments, we could just keep, let's see here, I can't really copy that. We could just keep manually calculating each one of these. All right. But here's the reason why I wanted to attempt to do this with both calculators, but I can only demonstrate it on the NumWorks. So on the NumWorks, if we go up to Graph, this Graph tab, and click OK, notice the shape of these ordered pairs, right? These ordered pairs have the normal distribution shape. So what we did is we just calculated the points along the edge of the distribution. And if we come back over to our notes, you'll see these are the same points that I've got illustrated here. So that's what a probability density function does, is it just calculates values along the line of the normal distribution curve. Okay. All right. So let's stop there before we move on to the next section. Let me know if you have any questions.